Hi, Math 30-2s. Today we're just going to be carrying on with logical reasoning and set theory, lesson 2, set theory. So just like day 1 or lesson 1, there is a lot of terminology in today's lesson. So again, have your highlighters out or things that you underline with, and make sure that we are making note of all the bolded and important things that I tell you to underline, okay? So it just says basically under sets and set notation, in mathematics, a set can be defined as a collection of distinct objects, okay? So again, that first word that we want to make sure we underline is set. For example, the numbers on the faces of a die form a set. Sets are usually denoted by capital letters. Okay, so again, that's going to be important, okay, or by a description inside of what we call curly brackets or braces. An object in a set is referred to as an element, okay, so an element is one of the pieces in a set. So for example, the number 5 is an element of the set of the numbers of a die. There are 3 general ways of defining the contents of a set. So 1, okay, we list the elements of the set. So for example, again, A equals 1, 2, 3, 4, 5, 6. Okay, so again, capital letter, okay, and you'll notice the curly brackets or the braces, okay, that contain all the elements of the set. And those are the numbers 1, 2, 3, 4, 5, 6, all the numbers on a die. Okay, so that's what we're talking about. The second way is to describe it in words. Again, we always have the capital letter, and we still have the curly brackets that begin and end all of the elements in the set. But this time we use words. So natural numbers that are less than 7. Natural numbers are numbers that start at 1, 2, 3, 4, etc. So whole numbers starting at 1. And the last way is using what we call set builder notation. Okay, and again, there's the capital letter. There is the curly bracket or the brace to begin and end the information, and the information that is inside is just like when we just talk about domain or range. Okay, so they're saying x such that x has to be less than 7, and then x is an element of n, and obviously n stands for the natural numbers. Okay, just like they had up above in the previous example. Okay, so n is natural numbers. Recall, so just some important things here that we want to know from previous knowledge. The curly brackets are read as the set of. That straight up and down line is read as such that. So that's in the third example of the set builder notation. And that E represents, and it is read as, is a member of. Okay, so again, just things that we've seen in grade 10 and 11 math that are coming back, and we have to know how to write or notate things properly. So for example, it says the number of elements in set A is written as n of A. So when you see an n in front of a capital letter A, that means the number of elements in set A. So for example, the number of elements in set A is 6. The number is 1, 2, 3, 4, 5, 6. There are 6 elements in that set. Note that the number 2 belongs to set A, but the number 8 does not belong to set A. To express this, we can say 2 is an element of set A, whereas 8 is not an element of set A. So we use the is a member of or an element of with a line through it to denote that it is not a member or an element. The order of listings in an element in a set does not matter. Okay, so for example, 1, 2 is the same as 2, 1. They have the same 2 elements in the set, 1 and 2. Doesn't matter the order that we write them down. So consider the following 2 sets. P is going to be whole numbers that are less than or equal to 3, and Q will be even whole numbers less than 10. So list the elements of each set. So for P, okay, we want to write down all of the elements that belong to P. So whole numbers less than or equal to 3. So 0, 1, 2, and 3. Okay, those would be all of the elements that belong to P. For Q, okay, again, even whole numbers less than 10. So less than 10 cannot include 10. So therefore 0, 2, 4, 6, and 8 again would be the last one in that set. Okay, complete the following. The first one is n of P. So again, that refers to the number of elements in P. So you count up the elements in P. 1, 2, 3, 4. There are 4 elements in set P. NQ stands for the number of elements in Q. 1, 2, 3, 4, 5. So there are 5 elements, okay, in Q. In part C, it says write set P using set builder notation. So that's the third way, okay, that we were going to notate sets inside or elements inside of the set. So what I would say then is I would go, well, we're dealing with a variable, okay, and we'll use x. So x such that x has to be less than or equal to 3, comma. Now x is going to be an element or a member of w, which stands for whole numbers. Okay, so that w stands for whole numbers. All right, good. D, which of the following, A, B, C, or D, is set builder notation that describes set Q? So we're looking for which option there, A, B, C, or D, basically represents even whole numbers that are less than 10. Okay, so when I do pick the answer there, even whole numbers less than 10, okay, our answer is going to be C. Okay, so we're just saying here in the set builder notation, we're going to use the element E, and E will be equal to 2 times x, so 2 times a number. So, and then the values of x can be anything between 0 and 4, because if I go 2 times 1, I get 2. If I go 2 times 2, I get 4. 2 times 3 is 6, and 2 times 4 is equal to 8. Okay, and those are the numbers that I want, right? 2, 4, 6, or 8. And actually the one I forgot at the beginning is 2 times 0, which is 0. So 0, 2, 4, 6, and 8, those are all the numbers. So for x, I substitute in anything between 0 and 4, okay, and I get all the numbers that I wanted in that set. Okay, good, all the elements in the set. So we're good. Turn the page. Okay, now terminology used in set theory. It says Betty is defining sets using non-negative single-digit numbers. From the list of non-negative single-digit numbers, she defined the following sets. So she said E is going to be even numbers, L will be whole numbers less than 7, and O will be odd numbers less than 7. List the elements of each set in the space above. Okay, so for E, just non-negative but single-digit numbers. So even ones are going to be 0, 2, 4, 6, and 8, okay? Non-negative, so the reason they say non-negative as opposed to positive is the number 0, correct? Okay, 0 is neither positive nor negative, so that means that we can include 0. L, whole numbers that are less than 7. So this is going to be 0, 1, 2, 3, 4, 5, and 6. Okay, it has to be less than 7, not or equal to 7, so I stop at 6. And O is odd numbers less than 7, so that'll just be 1, 3, and 5. Okay, so there are all of the elements, okay, for those sets. It says we will use these sets as an aid to understand some terms used in set theory. Okay, so the first important term here is going to be universal set. So within the context of any problem in set theory, there's generally some largest set that we have in mind. This is called the universal set. It is a set that contains all of the elements under consideration, okay, that are relevant to the problem. So state the universal set for the example above, and we'll call this set U. So if I was going to label that, I would just go U, capital U, equals, okay, and then I'll use words to describe the set. They are non-negative single-digit numbers. Okay. And that's basically, they told me that in the write-up of the problem, okay, and then I close that. Now, a subset, okay, as you can probably guess, okay, of a set is a set that contains some or all, or possibly none of the elements from a previously defined set. All sets we deal with in a problem must be, they have to be, subsets of the universal set. And every set is a subset of itself. So in set notation, so again, here's some very, very important symbols, okay, that we are going to be using. In set notation, this symbol is used to represent the relationship between two sets. So for example, E is a subset of U, so since all the elements, okay, in set E are also in set U, we denote this by the following. So E is a subset of U, okay? Is E a subset of L? If so, write the relationship using this symbol, okay? If not, we write it with this symbol, okay, a line through it. So take a look at E and L. Is E a subset of L? Okay, and the answer is no, it is not. So when I note it, it'll be E is not a subset of L. Okay. Now in the third point, it says set O is a subset of L, which is a subset of U. Write this relationship using the symbols. So we would say O, okay, is a subset of L, which is a subset of U. Okay, so 3 in a row there, using the same notation and the same symbols. So again, we have to know what that symbol means moving forward, because a lot of times they won't use words, they'll just use those symbols to notate things. Okay, next one, an empty set. So the empty set is a set that contains no elements, okay? The empty set, okay, is a subset of every set. So the notation for an empty set is the following right there. Okay, so for example, the set of all odd numbers, in set E is empty because there are no odd numbers in set E. Provide another example of a set that is empty. So if you take a look at all the sets above, another empty set I could get or give would be, for example, the set of even numbers in set O. Okay, so if you take a look at O, it's only odd numbers. So if I said I want the even numbers from set O, well, there are no even numbers in set O because it's only odd numbers. So that would be an empty set that I came up with. Okay, and then the complement of a set. The complement of set A is the set of all elements in the universal set that are not in set A. The complement of set A is denoted as A naught or A prime. Okay, so A with that little tick beside it means basically not A, or the complement of A. So write the complement of set E using the appropriate notation. So if I want the complement of E, it's going to be E prime or E tick, okay, equals, and then I'm going to list all the things that are not in E but are part of the universal set. So 1, 3, 5, 7, and 9. Okay, that's not set E because E was the even numbers, right? Single digit even numbers. So not E are going to be the single digit odd numbers, 1, 3, 5, 7, and 9. Okay, next page. Consider the following two sets. So A are going to be the natural numbers less than 20 that are divisible by 3. And remember, natural numbers start at the number 1. And B are the natural numbers less than 20 that are divisible by 5. Part A asks us to explain why the set of natural numbers less than 20 is a suitable universal set. Okay, well, the reasoning is because all of the elements being considered, okay, so all of the elements being considered are in that universal set. Okay, so I hope that makes sense. B says list the elements of the following set. So they want me to actually write down the numbers that belong to the description they've given in each set. So A, okay, nothing else there, just A. So A, I do want the natural numbers less than 20 that are divisible by 3. So that is going to be 3, 6, 9, 12, 15, and 18. Okay. B, natural numbers less than 20 that are divisible by 5. Okay, so that's 5, 10, 15. Okay, and then the last one, okay, that's the complement of A, okay, because of that little tick there. So everything in the universal set that does not belong to A. So that's going to be 1, 2, 4, 5, 7, 8, 10, 11, 13, 14, 16, 17, and 19. So those are all the numbers, natural numbers, less than 20, okay, that are not divisible by 3. C says write a description of the elements of the complement of set B in words. Okay, so the complement of B would be what? Natural numbers less than 20, okay, that are not divisible by 5. Okay, since B was natural numbers that are divisible by 5. Okay, now in D says they throw in a new set, set C, which are natural numbers that are less than 20 that are multiples of 6. Okay, multiples again mean you're counting by 6, so 6, 12, 18. State whether the following are true or false. So, you might want to put on the side here, okay, or go back up to wherever you want to do it up top. So the values of C are going to be, like I said, 6, 12, and 18. Those are the numbers that we are considering in set C. State whether the following are true or false. So now they've gotten into the notation, right? So in the first one, they say C, okay, is a subset of A. So are all the numbers of C in A? Yes, 6, 12, and 18 are all in A. So C is a subset of A. So this would be true. Okay. The second one, C is not a subset of B. So is C not a subset of B? So are all the C's not in B? That is true. Okay. C is not a subset of B. Okay. Now in the third one, very confusing. Okay. The complement of A, okay, is a subset of the complement of C. So the complement of A, okay, is going to be all the things that are not in A, and we wrote that up just above. So the 1, 2, 4, 5, 7, 8, 10, 11, 13, 14, 16, 17, 19. Is that a subset of the complement of C? So when you take a look at C, you're thinking of everything that's not in C. So 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 13, 14, 15, 16, 17, 19. Okay, so are the complements of A all in the complement of C? Okay, and when you take a look at that, that is also true. Okay, so all three of those were true. Okay, lots of notation there. So again, make sure you understand all those symbols and what they mean. All right, intersection of sets and the union of sets. Okay, so those two terms are very important. So first, we will take a look at the intersection of sets. Now, we will use the example on the previous page to introduce further terminology used in set theory. So again, they give me set E, set L, and set O, which we did use at the top of page 10. Okay, so if you just look to your left and at the top, you'll see those sets and how we define them. The intersection of set A and set B is called A and B. Okay, so when you see A and B, that is again what we refer to as the intersection of the two sets. And the notation looks like this. Okay, so again, three things there, all in one line. We have to know all three of those. It is the set of elements that are members of both. Okay, so they have to belong to both. Write the intersection of sets E and set L using appropriate terminology. So it would look like this. Set E and L. So E and L is equal to what? So what numbers are in both of them? Okay, they have to be in both. Number 0 is in both E and L. The number 2 is in both E and L. 4 is in both E and L, and 6 is also in E and L. Okay, so there's the appropriate notation and the correct elements. Now in the union, okay, so when we talk about the union of sets in A and B, we say that's A or B, and we notate it with that symbol. It is the set of elements that are members of either set A or B, or both. So it can belong to one or the other, or it can actually be in both. So we talked about this before. It's the inclusive use of the word or. Okay, that came from lesson 1. So it can be one thing or the other or both. Use appropriate notation to write the union of set E and set L. Do not write the same element more than once in a set. So once you've got it written down once, you don't have to write it again. So this will look like this, E or L. Okay, so I have to write down basically everything in the two groups. So when I combine those two groups together, it's going to be 0, 1, 2, 3, 4, 5, 6, and 8. Okay, so any of the elements in that set belong to E or L or both. Okay. And then the last thing here are disjoint sets. Two sets are said to be disjoint if they have no elements in common. So the intersection of the two sets is empty. So they have nothing in common, nothing that belongs to both groups. So for example, 2, 3, 4, and 5, 6, 7 would be disjointed sets, okay, because they have no element in common. When I take a look at the top there, they say which two sets of E, L, and O would be disjoint. Okay, so they have nothing in common. Which two? Okay, well, it would be set E and set O. Okay, those two sets have nothing in common, so we would call them disjoint. Okay, so one more example to work on the next page, and then it'll be time for you to get into the assignment and see how you do with that. So it says, consider the sets A, B, C from class example 2. So where U, the universal set, so again, U refers to the universal set, are natural numbers less than 20. A, where natural numbers less than 20 divisible by 3, and this time they're nice, they write them all out for us. B, where the natural numbers less than 20 divisible by 5, they write them out for us. And C, that was the set that we came up with on our own, the 6, 12, and 18, multiples of 6 that are natural numbers. So they're just going to use notation here and see if we understand what they're asking, okay? So in A, the first part, they're saying A, and that symbol means what? And B. List the elements of the following sets and describe each set in words. So for A and B, I want everything that's in both of them. Okay, it has to be in A and B. So when you take a look at set A and set B, the only thing that belongs in both, okay, is the number 15. So that is the only number or value that belongs to A and B. So they say describe that in words. So this would be the set of natural numbers, okay, less than 20, that are divisible by both 3 and 5. Okay, so there's the first one. In the second one now, okay, they are asking us to find A, and this symbol means or B. So basically I list everything in A and B, okay? And again, don't list an element more than once. So I want everything in A and B together because all of these numbers, okay, if I pick any of these numbers that I'm circling, you could say that they are in A or in B or in both, right? Remember we use inclusive here. So just list all those numbers. So it's going to be 3, 5, 6, 9, 10, 12, 15, 18. Okay, so when I go and describe that now, just like above, it is the set of natural numbers less than 20 divisible by either 3 or 5, and there you go. Okay. Third one now, okay? So let's see what we can come up with here. Now, in C, you'll notice again A prime there, okay, or the complement of A, so not A. So when you take a look at A, 3, 6, 9, 12, 15, 18, okay, not A again is going to be 1, 2, 4, 5, 7, 10, 11, 13, 14, 16, 17, 19. Okay, so those are the numbers in the complement of A. We want those numbers and B. So when you think about the complement of A and B, it has to belong to both. So the numbers that'll belong to the complement of A and B will just be the numbers 5 and 10. Okay, those are the numbers that are in the complement of A, okay, and in B. Okay, so how would I write that out? How would I describe that to somebody? Well, again, start the same way. So a set of natural numbers, the set of natural numbers less than 20 that are not divisible by 3, not divisible by 3 and are divisible by 5. There you go. Okay, so now we've done some explaining in words. We've written the elements in the sets they asked us for. Now they just want me to write the sets that are equivalent, okay, which again, equivalent means the same as. So B and C. So take a look at B and C, okay, and try and come up with a set that's equivalent to that. Well, if you take a look at B and C, divisible by 5 and divisible by 6, there's nothing, okay, less than 20 that's divisible by 5 and 6, okay, so just an empty set, disjointed, okay. In the second one, they're saying A or C, so I can have everything in A, okay, or in C. Now, if you take a look at C, 6, 12, and 18, those are actually all in A already, so A is the same as A or C, okay, because it contains everything in A and everything in C, so I could just write down A, and I would have everything that they're asking for. Now, A and C. So I want everything that belongs in both A and C. Okay, well, we've already said everything in C is in A, so I could replace A and C with just C. Okay, the 6, 12, 18, those are the three numbers that are in both. So that's the same as just saying C. Now, the last question, they've added another set, okay, which they call D, just 2, 4, 6, 8, 10, 12, 14, 16, 18. List the elements of the following sets. So again, they don't really give a description as to what that set is. They just listed some numbers. Again, you can see they're under 20 and they're whole numbers, okay, so they are natural numbers under 20. But here we've got symbols kind of everywhere. So it has to be A and B or D, okay? So what we're gonna do is we're gonna do the B or D first, figure that out, and then it has to belong to A and B or D, okay? So that's what we're gonna have to do here. So again, you've got your list of numbers, so we're just gonna look at them. So B or D, so that means everything in B and everything in D. So you're gonna combine those two together. And then it has to be A and B or D. So it has to be in A and B and D combined together. So when I take a look at everything in A, okay, and everything in B or D, the numbers that appear in both groups are going to be 6, 12, 15, okay, and 18. So those are the numbers that are in A and B and D together. All right, the second one, so it's going to be A and B. So A and B, the numbers have to be in A and B, and then it's going to be in there, okay, or in D. So when you take a look at A and B, do you remember what A and B was? That was at the top there. That's just the number 15. Okay, so it can be 15 or everything in D. So basically, I add the number 15 to set D. So it's just going to be everything in D, 2, 4, 6, 8, 10, 12, 14, and I add the number 15 in there, okay? And then 16, 18. Now, we have the solution there, or the set that they want, okay? It's in A and B, that was 15, so it's 15 or D, so we just add 15 to everything in D, and then any number you select from there will be A and B or D, all right? Now, the last one here, okay, lots of complements here. So it's going to be the complement of A and the complement of B. So we're going to figure that out first. So figure out the complement of A and the complement of B. So the numbers that are not in A and not in B together, and then the complement of that. So then take the complement of what your answer actually is. So when I do that, you think of not A, or what's not A. So that would be what? 1, 2, 4, 5, 7, 8, 10, 13, 14, 16, 17, 19. So that's not A, and not B, okay, which would be 1, 2, 3, 4, 6, 7, 8, 9, 11, 12, 13, 14, 16, 17, 18, 19. So the numbers that belong to both of those, and then not that. So I take the opposite of that. So when I do that, I will get 3, 5, 6, 9, 10, 12, 15, and 18. okay? So a lot of times we can envision what those numbers are. The other times, if it just gets to be too much for you and the list of numbers or the elements in the sets are too much, write them all down and then actually circle them as you're going through the questions, okay? And then it'll be very, very clear to you. So for example, like this one we just did, I can kind of envision the numbers. For you guys, you might want to write down the numbers that belong to each set. So write down A and then write down not A, okay, or the complement of A, and then write down B and the complement of B, write down C, the complement of C, write down D, the complement of D, and then much easier to see the numbers visually, okay, when you're picking them out and they're asking for solutions. Okay, so hope that really helped you guys. Again, as always, any questions, email me, take